Hello. When I was a kid, I went to an art school. There, I was told about linear perspective. At that point, there were a lot of things which were unclear to me. But now I understand it slightly better. If you're a physicist or mathematician, you will probably draw slightly better after this video, and if you're an artist, you will probably better understand linear perspective, like in a more formal way. First, I was shown that parallel lines, like train tracks, are supposed to meet at a single point. That point is called the vanishing point. I was like, okay, sounds right. Later, it was explained that sometimes there can be two vanishing points, like a building is seen from the corner, or like on this picture, each wall is drawn towards its own point. And in some cases, three vanishing points are used. That happens when a city is viewed from above or from below. Then the vertical lines are drawn to vanish as well. But actually, there can be even more than three vanishing points. And I was like, what? How is that supposed to work? Where are those points exactly if they're not always on the horizon? So in this video, I decided to figure it out. I did the math using nothing more than first year university stuff, maybe even high school level. You can also find a link to the Python code in the description. Now let's try to understand where all the points should go, including the vanishing ones. We are not doing rocket science here. People figured this out a few centuries ago, but it is now impossible to find out who was the first one. So let's say this cute little hedgehog is trying to draw on the canvas what he sees behind it. We will set the hedgehog eyes, the place he sees from, as the origin of coordinates 0, 0, 0. Now the hedgehog is looking at this apple. A light ray from the apple travels into his eye, passing through the plane of the imaginary canvas. If the hedgehog draws the apple exactly where the ray hits the canvas, everything will look right. But we still need to figure out where exactly that point is. Remember, we already placed the origin and the hedgehog's eye. Let's say the real apple has coordinates x1, y1, z1. And the point where the apple gets drawn on the canvas is x0, y0, z0. Since both points lie on the same line going out from the origin, their coordinates are scaled versions of each other. That means that x1 equals t multiplied by x0, y1 equals t multiplied by y0, and z1 equals the same t multiplied by z0. All we need is to find t. Then we can figure out the coordinates y0 and z0, the point on the canvas, and that's where should we draw the apple. But we already know x0, that's the distance from the eye to the canvas. So t just equals x1 over x0, and that gives us y0 equals y1 x0 over x1, and z0 equals z1 x0 over x1. Done! We can show this in a drawing. First, we draw a triangle by connecting the real apple to the point 0, 0, z1 with a horizontal line. Then we draw a vertical line in the plane of the canvas, and that gives us the intersection point. But this is just a graphical trick for this specific case. In reality, we already know the coordinates, we don't need to guess them. We can also draw two more apples the same way. We'll see that the apple farther away ends up closer to eye level in the drawing. It's the horizon. And the image of the green path itself goes toward a point on the horizon. But why is it point on the horizon? Let's try to find its coordinates. Let's say a line goes through the point x1, y1, z1, and its direction is given by the vector ABC. This is just how we can set a straight line. Then any point on this line can be written as x1 plus at, y1 plus bt, z1 plus ct. And we already know where exactly this point will be at the canvas. So y equals y1 plus bt over x1 plus at multiplied by x0, and z equals z1 plus ct over x1 plus at multiplied by x0. Now let's take the limit as t goes to infinity, so the line itself goes to infinity. Then the line goes towards the point b over a x0 and c over a x0. Let's look at the special case. Suppose the line is parallel to the x-axis, like train tracks or rooftops on the street we are standing on. Then b equals c equals 0, and the vanishing point is just the center of the horizon line, which, by the way, is at the eye level. Now let's take a line which lies in a horizontal plane and goes at a 45-degree angle to the x-axis, either to the left or to the right. That means that the direction is 110 or 1 minus 10. And if we find the vanishing point at the same way as before, we get the vanishing point at the coordinate plus minus 1 multiplied by x0. So the y-coordinate of the vanishing point becomes plus minus x0, which means that on the canvas, these lines go to either minus x0 or to the plus x0. Great. This way we can find the coordinates of any vanishing point. Now, there's one more subtle thing to talk about. For example, then we have 3 vanishing points. This usually happens when we are looking at the city from above or from below, but in that case, things don't work exactly like before. It's not just like this on the picture, it is somewhat strange. It is the whole coordinate system, including us and the canvas, that is turned. So we should turn everything so it's better to say we are looking downward and the canvas is rotated with us like it is right now. And then everything else, all the points, all the lines, has to be seen from this new rotated angle. But it is still the same story, computations are the same. The Python code, which you will find linked in the description, does exactly the following. The first script takes any quadrilateral, you can define it by giving 4 points, just their coordinates, and then see how it looks in the perspective. Right now it's set up with a square because that's what comes up most often in real scenes. The second script does the same, but with a 3D cube. You can set the cube's center position and also its orientation in space by choosing 3 Euler angles and see how it looks in the perspective. Thanks for watching. Hope perspective makes at least a little more sense now. Hi, it takes a lot of time and effort to create this content. If you find it even slightly helpful, your feedback and support, especially subscribing, really helps me to keep going.